Hello guys, I would like to talk about random variables in this video. And specifically, I will focus on the discrete random variables. When we talk about random variables, we should discuss the basics of probability concepts. If you remember, we were talking about sample space. We were talking about probability of an outcome. We were talking about an event, which is a subset of the sample space. So you remember all these details. So that's why I would like to jump into the concept of random variable immediately. So a random variable is a real valued variable whose value is determined by an underlying random experiment. Okay, this is a little bit confusing definition, but I would like to underline real valued variable and underlying random experiment. So let us move forward, and then I will try to explain things using some examples. For example, in a soccer game, we may be interested in the number of goals, number of shots on goals, number of corners, number of falls. All these things are numbers, right? So we might be interested in such numbers that would explain the random experiment, which can be explained as a soccer match. Okay, so you might say there were this number of goals, this number of shots, this number of falls in a certain soccer match. So soccer match is a kind of random experiment in which you might get different numerical values, and these values will be our random variables. So let us start with something that we already know. Okay, we were talking about tossing a coin or flipping a coin, and we were checking the number of we were checking if the outcome is heads or tails. But this time, arkadaşlar, it's a little bit different. Okay, we are not interested in the outcome is heads or tails, but we are interested in number of heads, for example, or number of tails, for example. I'm tossing a coin 5 times, and my random experiment has 2 to the power 5, which is 32 possible outcomes. And as you see, possible outcomes range from all tails up to all heads, and all these outcomes will vary for each flipping. So we are not interested in these outcomes anymore, but we are interested in the number of heads. Okay, number of heads. For example, here I have 0 heads, here I have 1 heads, or I have 5. All of the outcomes are heads, which is like the number of heads is 5. So I'm interested in number of heads. This will be my random variable for this random experiment. Okay, it's not going to be like the probability of heads or tails, but we will be dealing with the number of heads, the number of something, and the probability of that number happening. Okay, so as you can see here, the possible random variables, like x will be my random variable, which is the number of heads. Okay, number of heads, and it might range from 0 to 5. 1 means there is only 1 heads. 2 means there are 2 heads when I flip a coin 5 times, and so on. Okay, so if we think about the this flipping a coin 5 times example again, what for example, my random variable is x. If there are 5 t's, my random variable value is 0. If the value is 2, there are a couple of outcomes, like which has 2 heads in it. Okay, so that's what we are talking about in terms of random variables. So if you look at the books or different resources, you will see that random variables are represented with capital letters. Okay, x, y, z, something like that. Okay, so we will be talking about random variables, and usually they are represented with capital letters. And while talking about random variables, we will also be talking about the range of random variables, or all the set of all possible values. For the previous case, it was like no heads, okay, no heads, and all heads situation. That means five, number of heads will be five, and the possible outcomes will be changing from 0 to 5. Okay, let us talk about some range examples arkadaşlar. If I toss a coin 100 times and let x be the number of heads I observe, what would be the range? I would either obtain no heads, or one heads, or 100 heads. All of the possible outcomes might be heads, and so the number of heads might be 100, right? So if I toss a coin until the first heads appear, okay, the first heads appears, let y be the total number of coin tosses. I might toss a coin, flip a coin, and I might not get a heads. I might get tails, okay? First tails, second tails, third tails, and fifth, fourth heads. Then I will say my random variable will be 4, because I am interested in the total number of coin tosses until I obtain the first heads, okay? For example, if I obtain heads in the first flip, then it will be 1. If I obtain the first flip in the second or third case, it will be 3. So I will have an integer as my output, and the range will range from 1 to 1, 2, 3, and it might go further, right? So if we talk about the random variable t, which is a little bit different than the other ones, is defined as the time in hours from now until the next earthquake occurs in a certain city. Okay, in a certain city in Indonesia, for example. Okay, what would be the range? It would be, the range might be like t will be a real value, which is not integer this time. Okay, real positive or positive real value. Okay, for example, 0.000012 hours, okay, or 10.220 hours, right? Or maybe millions of hours. So it might occur very late. So we might have integers like that as our random variables. Our range might be limited like that, or unlimited like that, or it might be integer or a positive real number. So it might have different applications. So we will mainly focus on discrete random variables for now. And if we talk about discrete random variables, like the number of heads, number of kicks in a match, number of people entering a shop, number of defective parts in a process, in a manufacturing process, or number of workers working in a building. Okay, all of these might be random variables. If we talk about random variables, we should also be immediately talking about probability mass function. Okay, probability mass function is a very easy concept arkadaşlar. For each outcome, I will be talking about the probability of that outcome, and then I will come up with a function or a plot that shows the probability of each possible outcome. Okay, the probability of each possible outcome will be shown as probability mass function. Okay, for example, I will toss a coin 2 times, okay, and it's a fair coin, which is like the probability of obtaining heads is, or heads or tails is like 1/2. Okay, this is called fair coin. And I'm interested in the number of heads when I flip a coin 2 times, okay? So what's the range? Let me give you the possible outcomes, okay? Tails, 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 heads, heads, tails, and heads, heads, okay? So these are the possible outcomes. How many heads do I have here? 0. How many heads? 1. How many heads? 1, okay, and 2. So this is all I have in terms of number of heads. And then now, what is the range? 0, 1, and 2, right? 0, 1, and 2. What is the possible probability mass function? Like Px, x equals 0. That means the number of heads is 0. There are 4 possible outcomes, and 1 out of them will be no heads situation. Probability of x equals 1. That means number of heads is 1. In 2 cases, I will have 1 heads. So that means 2 over 4 or 1 over 2. Okay, probability of x, x equals 2. That means if I flip a coin 2 times, and I will have 2 heads, and it will be, again, 1 over 4. Okay, so I will plot my probability mass function right now. If I say this is 0, this is 1, and this is 2, it will be like 1 over 2, 1 over 4, 1 over 2, and then 1 over 4 again. Okay, this is 1 over 4, 1 over 2, and 1 over 4. So this is how I should plot a probability mass function.